Welcome. Today we will look at advanced FDL in dbWatch. This webinar focusing on the more advanced techniques for exploring system metadata, building flexible FDL queries and reports that work across heterogeneous database environments. Today we will focus on how FDL works, how we can define properties, and how we collect data from the databases. Also, we will look into how FDL works across different database platforms and how the syntax changes and how we create the syntax. We also look into how to create your own properties, and this is a unique capability to allow us to query with new metrics that are not added by default. And also on top of that, we have FDL functions that allow us to correlate and summarize and look at data together and make the FDL queries even more powerful. Today's presenter is Marek Jablonski, Chief Technical Officer here at dbWatch. And please, Marek, can you introduce yourself?
Thank you, Per. Hello, everyone. My name is Marek Jablonski, and I have been working with dbWatch for over 20 years, mainly as a DB developer, and spending a lot of time with FDL. And today I'm going to share some of that knowledge with you. But before I start, I would like to introduce you, or show you at least our environment where I will run a lot of FDL queries. So now I will switch into the environment and just show you the dbWatch monitor, how it works and where to find the FDL console. So here's our test environment. This is the monitoring part. I am connecting to two dbWatch servers, and both of those servers monitor different platforms, database platforms. So this is the monitoring part, which I assume most of you are very familiar with. This is the management part, where you can interact with those different instances, do the changes to the instances and so on. Then we have farm views, where you get different views of the whole environment. Actually, all those views are based on FDLs. So the monitor actually sends FDLs to the dbWatch server, and the dbWatch server returns data. And then we have SQL worksheet, where you can run normal SQL against those instances. And this is the discover part, and the part we are going to focus on is the FDL console, where we are going to type our queries. So that's the test environment I'm going to use today. Now we will switch back to the presentation, and I will just talk a little bit about FDL before I actually start to type. So let's down. So what is FDL? So FDL is a farm data language created by dbWatch, and it's meant as an umbrella on top of all the SQL dialects from all the platforms dbWatch is supporting. So we are supporting 6 different database platforms, and also actually MongoDB, which is not a SQL database platform. And with FDL, the point with FDL is to query the whole environment, not just one instance, but the whole environment. And it's just a query language. So it's, you don't do an insert, update, and delete the way you do in SQL. It's just a query language. So just to compare, so select, when you run select, the building blocks of the select will be columns and tables mostly, where you type the select and then the column names and from and table, and you'll get the result. In the FDL is more like a path query language, where you type just names of properties, and the properties will return values to you. So, and you type it the way like directory structure. So the properties, as I mentioned before, are the building blocks and of FDL. And let me see. And properties can can return one value or set of values, or properties can have sub-properties. And we have mainly three types of properties. We have system properties, SQL-based properties, which we'll focus on today, and metadata properties. I will also show you how to use them. System properties are built-in and hard-coded properties in dbWatch, which are there even before you start monitoring any instances. There will be a set of properties you can run in FDL to get information about the whole environment, the name of dbWatch server, groups, and so on and so on. I will show you some of them. Those cannot be modified. They're just part of the system. And it, as I told you, just gives the overview of the whole monitoring system. So that's the system properties. And we have SQL-based properties, which are based on SQL statements, selects. So when you type a property, what actually happened behind the screen is that dbWatch server executes a query and returns data. And we have around 3,000 predefined properties. On every new version of dbWatch, we get more and more of those properties. So we just translate a lot of SQL statements into the FDL. And of course, SQL-based properties, you can create your own. And today we are going to, I am going to show you how to do it. And we have also metadata properties, which are less flexible. You just add some extra information to your system, but they are not dynamic and very little used in dbWatch. Even they are very powerful. I will show you where to find them and how to actually add them. They are nice to have as something extra to the SQL-based properties. So how those SQL-based properties works? They are kind of aliases to statements. So there are a lot of statements, predefined SQL statements, and they're just translated into those FDL, and we are going to do it in a moment. And what's important that some of us in dbWatch we're trying to have properties which work across all platforms, but of course some of the properties they will be platform specific because there's, let's say when we talk about RAC, real application cluster, then we know that those properties are related to Oracle platform. And when we talk about always on properties, they are related to SQL Server, Microsoft SQL Server platform, and so on. So those properties, some of them are of course cross-platform, which are very nice to have. They're very powerful, but many of them are also platform dependent. So that was just short introduction to those different types of properties, which is nice to know about, and what the properties actually are. So now I will switch into the demonstration, and what I am going to show you, I will just show you some system properties, and I will show you some metadata properties, how to create them, and some SQL-based properties which already are there, which you can query yourself. And then we are going to look at the card catalog table and try to translate SQL selects into the FDL and see how we can query this card catalog table using FDL. So let's go into our environment. Here's the console. Here you can type those different properties. When you type a property, the dbWatch server will execute SQL statement on the instance if it's a SQL-based property. So, but let's start with the system properties. Here I just type number, just value1, which is not a property. When you type a value1 and hit control execute, you will just get this value. It's the same like you run select one, or I could do like this, Marek, and like this, and I will get value Marek. That's not the property, but it behaves very similar to select. So let's start with first property. As you remember, we have two dbWatch server. So what I could do, I could type name server like this, and I will get two values. That's the ID of those servers, and the server will have a subproperty name name. So if I run this, I will get the mu4 and the mu3. So that's the system properties. They're hard-coded. You don't run any SQL behind. It's just part of the dbWatch, those system calls. I can also run server and grow like this, and execute, and I will get all the groups on those servers. Of course, when I typed, because the group is a subproperty of the server, and when I type like this, it will only return the last column or last property I'm putting. So if I want also the name of the server, I would do something like that. In that case, I would just get the ID, and so I will get the ID of the server, and I can see the groups for this server. And since the group is part of the server property, I can do something called anchor. So I define an alias to server. So what you do by typing an error, and I can choose the letter, let's say S, and then I put name. So if I run this one, I will just get a name of those two servers, and then I would like to also add the group for that server. Then I have to specify the alias for the server, and I will get the group. I don't need those curly brackets on the last column. It will always display, but you can have it too, like this. So now if I run this statement, I forgot letter S. So it's like typing server here. So first I get the name of the server, and then I get the groups for those servers. So now I can see the me4, and I can see the groups there, and the me3, the groups there, and so on and so on. So that's the system properties which are there. And when you actually click in the monitoring here, you will it runs a lot of server FDLs behind. So let's go back here. So that's the typical example for system properties. As soon as you add instances to your system, like here we have almost 90 instances monitoring, we could the instance is the system property, which will be created as soon as you add the instance. So if I add the instance like this, I will get the server and all the instances in the second column. Of course, that's the ID for each instance, and probably it's better to type name like this, and run it once again, and I get all the instances from those groups. That's the system properties. And there are a lot of SQL Server SQL based properties. For example, we have a property name dbCount, and that's actually a property which is available on all platforms, even on MongoDB. So you can, and this property returns just one value. It's predefined, it's there, so you don't have to create yourself. So the name of that property is dbCount. So it's a subproperty of the instance. So if I type dbCount, I will get the number of databases on each instance. So now I have the server and name and instance, that's the system properties. DB count is a SQL based property, because here what happens when you type DB count, dbWatch server understands, when on Sybase I run this query, on SQL Server I run this, on Oracle this, and there will be different queries run from dbWatch server. It's kind of just an alias for those statements, and those select statements return just one value. So I can do like this. So I get the demir and I get the number of databases for instance. I would probably like to have the name of the instance here too. So now I would have to create another anchor. Let's say I for instance, and then name like this. And then I have to refer to the instance. So I will type $1 like this. So I have server and name, and then instance, that's the property of server, and instance name, and db count is a property of instance. It looks maybe a little bit confusing, but it's very simple and logic. So now let's run. So I will get the server name, the dbWatch server name, the instance name, and the number of database on that instance. That's one of typical SQL SQL-based property. We have another property named database, like this, database. And this property is also available on every platform. This property returns not just one value, but many values, depending on the platform, of course. All the databases defined on that instance which you monitor. So now if I run this one, query will get much larger. I get 535 rows, and I get the names of the instance, the names of the databases on each instance. So here we have another SQL-based property, which is there, one of those 3,000 properties, which returns many values. Actually, the database property have also sub-properties, and those have other sub-properties and so on. So they're quite complex property. But when you just type just the name of the database, you will get the names of the database. So that's the system properties and the SQL-based properties, and we are going to create our own SQL-based properties based on this car catalog in a moment. But before that, I would like to show you how to add metadata. We do not use. Actually, per default, there's just one predefined metadata property named location with values. There's different continents, Europe, Asia, Africa, and so on. They're just as an example. We have it in dictionary. They are not used, but you can play with those. So there is just one metadata property with our product when you install it, but you can create your own. So let's say if I go back here to the monitoring part and I just select one of the instances, let's say I choose one of them here, I can click on configure instance, where I get some information about the configuration of the instance and so on. You can see general, some authentication stuff. And the third one is metadata. And here you can add new properties. Actually, I created a property. I was the companies is not there. That was the example I was supposed to use here. So I can add a property name company like this, and I can okay. So supposed to remove them before this presentation. My apologies. And okay, I add the IBM and add it like this. And I suddenly created a property name company with value IBM. Save it first. Okay. Then it's company. Okay, next. once again, db names. Okay. This is something strange. Then I have to just switch to something else. So here you can actually define your own properties and add them. And so at least we added a property name company. I will type it here. So now if I go back to FDL, I could, instead of checking the name of the databases, I could check the company like this and run it. And you can see this instance has a property name company with value IBM. Actually, I just get one record because there's just one instance with that property. I could add it to a different instance, and let's say just click on this one. Here I add the configure instance and metadata and company, okay, and Microsoft, okay, add, save, okay, like this. And I would go back to FDL and run this once again, and I get two companies. So, but those values, they just have some, you define what values those properties can have, and they are of course not dynamic, but they can be used in FDL if you want to describe your system, if you want to add some information about that instance, how important it is, or company name or location, and so on. So that's the way how you can do it. When you type a question mark, you will get the result from all the instances, even you don't have any values for company. And of course, if you have a huge environment with 1,000 instances, you don't do it like I did manually. You can use the metadata editor here. So company okay, so I forgot to remove the company property. That's what happens. I was trying it yesterday and I was supposed to remove it. So usually if you open your dictionary, you would just find the location property, metadata property with those values, Europe, Africa, and so on. And here you can add other properties. So I could add dbv names, if I was trying to add like this. And then I can add names Marek like this. And I could add Per and so on. And so those values, so the dbv names will be Marek, Per, and I can easily add them to many instances because they will be a part of the dictionary. That was the reason why I couldn't define them, because those properties already were there. Okay, so that's the dictionary. So I have company, as you can see, with 3 values. I have location, and I have dbv names. That's 3 metadata properties, and those properties you can easily add. Let's say I can select the production instances here, and I can say location like this, for example. Click on multiple and choose that they're in Europe and apply changes. And this is a way to add values, those properties, add the properties with values to many instances at the same time. So it's like this. And now if I use the location like this, I will get location for those different instances. If I remove the question mark, I will get just the instances with those properties. So that's just a few examples on system properties, SQL-based properties, and metadata properties. Metadata properties, we have just one location. Here I have the 2, now I have 3. You can easily add your own metadata properties. Those are the easiest to add properties, because those SQL-based properties, then you have to actually know how to type SQL, and there's more work with that. And we don't have any graphical interface for adding your own SQL-based properties. So now I will show you how to translate information from a table to FDL. And I already created a database name car on some place. And here you can see how powerful the FDL is, because now I could ask, run the FDL query, and just to find where can I find the database name car. If you use normal SQL language, you have to connect to one instance and check is there any database with name car, and you have to do it for all the instances, and at some point you will find it. Of course, you can run the same query at the same time from the worksheet, but it's more convenient using FDL, because you just type here and you get information from all the instances at the same time. So so we have name, we have database. So if I go back to database here, and database like this, I will get the result of all the databases. Here I could actually use the filter car and actually find the instance where I have this database. But let's say instead of running the whole query, FDL query, you can use where clause in FDL. And for that, we are using those different brackets. As you see, we already introduced those curly brackets, and they are usually to format data. So you can, if you want to have a name of that column, you would, so this is the server name, then, so you can actually format the output, and you can add if it's numbers, you can say render int or render float, or maybe it's a date, then you can format the output for that property. So that's the curly brackets. But if you want to use a where clause, you use the square brackets. And I will show you how to use it, because here we have all the instances, but we just want the instances. Let me say, and so we put the where clause, that's the square brackets, where database. You can type like, but of course we do like the database car. I think I have to specify, because this is a little more advanced. I think I have to do like this. Database. Database, right. Name. Let me see, data instance, database. Okay. It should be like this. Sometimes I run into some problems. Of course, I could, instead of getting stressed, I would just remove this from here, and I will add database and say with name. I could put it like this and run IP like this. Sorry for getting stress. Yes, so here I add that the ID of the database is car. So now I just run, I have kind of where clause inside the square parentheses. So this is the database where I have this table. So let's just switch to that database and take a look at the table and see what kind of data we have in that databases. So now we know this is the instance where we have data. And I will go to the management part and filter it here. It's there. Okay. I will open here. So here's the management part where you can administrate the whole instance and databases. And we should have a database with name car. And then we have schema, and then we have some tables, and there's just one table. And I could just click here and get view all the data. Actually, I would do it. I will just do it differently. I will go to here, and I will just type. The whole table is actually quite large. The name of the table is car catalog, like this. So, and I run it. Should type from like this. So from, and then execute. So you can see I have a lot of columns. So instead of looking at all columns, I already prepared a select for us here. We can first take a look at those. So now we have a query like this. And now the question is, okay, how? I will just clear up, I'll put it on once again. So how to translate this kind of information into the properties, so you can run, so you can select, query data from that table using FDL. So before that, I will, before creating definition of that property or a set of properties, I will create some very simple properties, which just extracts portion of the information from that table. So if I just go straight to the file, so to be able to define those properties, you have to create your own file. So we don't have any graphical interface for creating your own SQL-based properties. So you have to just use your favorite editor and create your file. And you will need to specify a kind of header in that file, which will identify that file. And each file must be unique with when you look at those three values: the version, company, group, and artifact. Actually, four values. So those values together, they create something we call artifact. So artifact ID, group, company, and version will create artifact, and that value must be unique. So when you create a new file, you will have to specify something, or those four values might be different. And of course, you can create a lot of properties in one file. So you won't need many files, maybe one, two. But just remember that the file must have a unique artifact. And here I would just show you how I defined some properties, some very simple property. I create a property named car brand count. So as you can see behind, there are some brands, Toyota, Volkswagen, and so on. This property will just will return number of unique brands. So the property, the car brand count, will just return one value. So this is the way you create a property. It will have compatibility. Now I am using SQL Server, so there is actually a FDL with you can see with brackets with word clause in it. So the data type must be SQL, and the database /ID must be, you must have a car database. Otherwise, you cannot run this statement. So when dbWatch server runs this statement on SQL Server, it will find only the SQL servers with database car. So this will translate into that. So you will see it in a moment. Here's a different way of adding two values at the same time. So now I have a select where returns two values, and in that case I can add values to two properties at the same time. So it's just more complex way of defining the simplest property with just one value. And then I created a car branch. So here, so the car branch property, like databases property, it will return all brands in a car catalog. So I will get a lot of values. And the most important and actually the only one you need, because if you create this one, you can run FDL with functions and you will get this information. So you actually don't need to define those properties when you define this one. But this one is a little bit more complex to define. As you can see, here we have a car code property, which refers to unique column, the first column of the table. And then for each value of the car code, you will have brand, that's the next column, model, model year, and so on. So those properties are sub-properties to car code. So when we ask for those values, we will type car code / brand, car code / model, and so on. So that's a little bit more complex way of defining. So here you have a property with 1, 2, 3, 4, 5, 6 sub-properties. And you have the select which we just run. The select returns 10 rows and 1, 2, 3, 4, 5, 6, 7 columns. So this is the way you define a property with sub-properties. And of course, you can also create a property based on on other properties. So you don't have to run SQL. You can also run FDL if you want. And there are some other tags you can see for how long this property is valid. Because let's say if you have a property name host name on the instance, you don't need to run it, execute the statement too often, so that it can be valid for a day or two, or even as long as the instance is up and running. So some of the properties will have long time, they will be valid for a very long time, and some properties, let's say if you have a property name sessions, it's the number of sessions on the instance, and you will probably want to, when you execute, you want the value which is right now, so then you put it in maybe 10 seconds. So that's those properties. And when you create a file like this, you have to import it into the dbWatch server, so dbWatch server knows that those properties exist. And you will do it exactly the same way when you import jobs or some management fix. You use the server here and upload resources. And actually, I don't have to import it to both of them because the instance is just on the Demir tree, but you can do it on both depending on what kind of properties you are defining. So let's find the file, and here's the car catalog, which we were looking at. Open and then upload. And as soon as you upload the file, then those properties are available if you don't have any syntax errors in the file. So if the file is created properly, those properties will be available at once on the server. And also, if you want to remove them, you will have to find this file on the field system and remove the file manually. So now if we go back to FDL, we have the instance, we have this one. What we can do now here we have the instance. Actually, what we could do, I could put the filter, so I just run queries against only that instance. So instance name, and I would put comma here like this. So once again, if I type name here, I would just get one value. I remove, let's say here, I could do, this is the formatting, so I could hide. If I do like this, the column will be hide. I can also, actually, I don't need this anymore. So let's go into our file, and remember we defined some very simple properties. So this car brand count property is a sub-property of that instance. So if I copy the value here and put it like this and execute, I will get the number of records in this car catalog, which is 10. And so that will be one value. I could check the other values. So let's say and if we go back and let's say body type count or fuel type, maybe, then I will get then we see we have 5 types of fuel and we have 10 brands. So what dbWatch Server do is run those 2 SQL statements against that instance and get the values, and those values those properties will be populated with those values. So that's those 2 very simple properties. So let's take a look at the more advanced property, which returns many records like this. So I could specify it behind. Once again, it's anchor I because I refer to the instance all the time. I dot car brands, and if I run it, I will get 10 records of it. It's 10, 10, 10, 5, and so on, and you get the car brands. So probably this information is not so. I don't need it actually. Do it like this. First column, I don't need to specify $I. So I just do like this. So here is the car brands property, which returns a lot of values. So let's now take a look at this property and sub-properties. So we have car code. So if we now run the car code, then we will get the values of the first column. And if I want to get the brand value, the brand is the sub-property of car code. So I can put it brand like this and execute, and I will get brand. And if I want to use next, let's say also get model, okay, then I will have to anchor the car code. Okay, car code, then I will use the arrow, and then let's say C. You can specify any letter you want. So now we have brand, and I have to use those curly brackets. So that's the brand, and now I use the C anchor like this, and I put model like this. And now I execute. Now I get 2 columns. Also, I can, after car code, I could get values for car code 2. So I will get 3 columns. So I now have car code, I have brand, model, and so on. And I can continue like that and add those other properties. And it would turn out that I have exactly the same value here. I get the same result as as in FDL. So let's just finish the result. Actually, I have it here more or less. So let's say if I do like this, you don't have to type it on one line. You can do like this. So you can see here, you can very easily translate. So this is the translation of the statement here. So here we have select all those columns from car catalog, and here we have a different way of specifying the same query. if you run just against one instance, you would probably use SQL. But the point is, when you have many tens of hundreds and even thousands of instances on different sites, it's so much easier to translate this kind of SQL statement into the FDL and run it as a properties. And when you define the car code property with all those sub properties, you don't need those small properties which find the number of brands and the thing, because you can use functions and just get the information. So let's say I prepared already some statements for you. So if we want to just check the number of records in that table, that will be the number of brands, I can just use the function count. So I don't have to define this properties. Remember, I was defining this property car brand count. I really don't need it because I have the main property, the car code with all the values, and now I can use functions and get this kind of information the same way you do in SQL. So I will just show some of those functions you can use. So here will be another, it's a little bit different syntax. So here I count the distinct body types. So I just, so you have SUV, you have different body types. So car code, instance car code. So actually I could body type. I can run just like this. So we have sedan or SUV and wagon and so on. So that's the body types. Okay, let's take a look at some other. You can also use the group by, which is not so easy at the beginning, but when you start typing your commands, it will look much more logic. So at the beginning, it's a little bit, maybe a little bit complicated. So here I run, just see how many cars there are from those different countries. So you run and can type it like this. There's another one where you can group like 2 columns. So there are, of course, more complex SQL statements which you can do. So instead of running as a SQL, you run it on the dbWatch server. So dbWatch server actually gets all the data and do the grouping on the dbWatch server side, if you want. So it can be done from dbWatch server. And the nice thing is when you do it, when you have results which you cannot group on the instance. Let's say you have, you remember we did have query like instance and then db count. So this one returns all the number of databases from all the instances, and there's no way you can sum those values in SQL because it's from different sources. So here it's so much more powerful with FDL because then I can use sum like this and suddenly sorry, because I have to do like this. And now I very quickly find out how many databases there are all together on all my instances. Otherwise, if with SQL, it's just not possible. So you can see it's really powerful, the FDL, and as soon there are some queries you want to run against many instances, it's very convenient to translate them into the FDL, and then you can query the whole environment very, very easy, and it's very powerful. And as I mentioned, all those statements here and also in the farm views, they're execute the FDL executed. And if you want to look at them, you can actually use the help and debug and query log, and you can see what's can remove the SQL. And when you push the button, you will see those different SQL statements we run against the dbWatch server, so you can get some nice examples and see what's going on. And the same if you go into the dbWatch, the monitoring part, and you click on some group here, you will see there's a lot of different FDLs there. Some of those here you can also actually open and see the code. Let's say if I went to the mir, and here you can see, so this is the information about all the instances on the mir, and you can actually click here, edit, and you can see the code running behind. So this is, I can just copy it like this. Control C, and I can go back here. I remove this one. Maybe I can start a different new console like this, and execute trigger like this. And you can have spaces. It doesn't really matter. I can remove those state spaces like this. So you can see it's quite complex. And when I run it, I will get exactly the same value. So you can see there's some formatting. So I get some icons. So and then I can get some bars. So the FDL is quite an advanced query language, and you can really create your own views and just add your own properties and expand our product with information just relevant just for you. So that's basically all I had to say today. So I will now switch back to the presentation. Per, you can take it from here.
Yes, thank you. We have some questions in our question and answer window. So it comes to documentation for this. Is there like a list of FDL properties or guides and things like that that people can use to dive into this on their own?
Yeah, you can answer, or do you want me to answer?
So if you can open the wiki, we can show people where it is.
I mean, you can probably open the wiki from here. Can
Yeah, you can go
help?
to the question mark at the end, or click help. So it's the help module there, or might open in a different window. So you might have to put it into, yeah. So if you either click on help there or go to the question mark in the browser, you'll open the wiki. And here on advanced topic FDL farm language, if you expand that, available properties, it will list these defined properties and what kind of what they'll contain, what type of values you properly get, and things like that. That allows you to go through and see if there are already defined properties that are what you want to query on, basically. So it's a starting point before you create your own, but also in the customization area so under customization, a bit up here, and then property system. There is also examples on defining both the static metadata properties, dynamic properties like you have here, and also even more advanced properties than what Mark displayed today, which are JavaScript-based properties that can also execute code. Additionally, we have questions regarding advice for naming and things like that on properties. And I think, I mean, you can create properties for everything. If you load up properties that are overlapping the property names that are defined in the application. Local properties take precedence. But if you want to avoid conflict, we suggest that you put some unique letters for your company or something like that in front of the property name, so that you know that it's properties that you yourself have defined. That's all the questions we had today. If you want to try out dbWatch Control Center, you can scan the QR code here on from this webinar. Also, it's possible to book a technical meeting to look through how FDL or dbWatch can help you fulfill the needs that you have in your database environment. And you can also go onto our webpage to both book a demo or to start your dbWatch trial today, if you want so. I think that's all we had today. Thank you, Marek, for this great presentation. I think it's useful to dive into the more advanced topics as well in dbWatch, so that DBAs that want to take it to the next level can know where to start adding to the product. Thank you all for attending this webinar today. I hope to see you again at time in the future.
Thank you so much. Bye-bye.
dbWatch Control Center, redefining database operations. Please visit us at Facebook, Twitter, LinkedIn, or YouTube.